Informed search strategy. So here the other name for informed search strategy is heuristic searching. So here it uses the problem specific knowledge. The approach what you're going to discuss is best first search. So here the node is selected based on what the evaluation function f of n. So every time if you want to expand a node, you have to it should be done based on the evaluation function f of n. So here, as far as this best first search algorithm is concerned, you will be having different evaluation function, but each of the evaluation function will have what and heuristic function. So heuristic function h of n is what the estimated cost of the cheapest path from the node n to the goal node. So for example, if you're taking a route planning problem, so often you will be visiting different cities, so every time if you want to move from one city to another, you have to choose the cheapest path. So that's how you will be every time. That is the heuristic what you are going to apply should be of what should choose the cheapest path. So and also it uses what SLD, that is straight line distance calculation. So in an informed strategy, you have three different functions. So one is g of n. So g of n is what the cost from the initial state to the current state, and whereas the h of n is what, as I said, it is the cheapest path from the node n to the goal node, and evaluation function, which is an important component for the informed search, called as evaluation function. That is, you are going to select a node for the expansion and make sure the node what you are selecting should be of lowest cost. And as I said, you have what you are following a straight line distance calculation, and you have another thing called Manhattan distance. So in SLD, that is straight line distance calculation, so you are calculating the distance between the different nodes, so that make sure you have a link between the nodes, right? And in Manhattan distance, so it will be calculating the, that is, it could move the horizontal way and the vertical way, and every time while switching from one state to the another state, so it has to be, it should have what this lowest or the shortest distance. So in that way, so it is classified. And the next is called as what GBFS, that is greedy best first search. So in GBFS, you expand a node every time, so that make sure the node is very closest to the goal. So in that way, we come up with an equation like f of n is equal to h of n. So f of n is what the evaluation function, which is equivalent to the heuristic what you are applying. So that's why the name greedy search. And here this, in this greedy search, it is going to use what SLD, that is straight line distance heuristic, that is you call as HSLD. So here you have an example, that is it's like a route finding problem. So you have to start from Arad and you have to reach the location Bucharest. And I told you you have what HSLD, that is straight line distance calculation. So without H of n, you cannot solve this problem. So that's why you have what the distance of each of the locations here, right? So you have to cross each of the cities. So HSLD for Arad is what 366, and you have to look for the closest next node you have to find out. So from Arad, what are all the reachable cities are Shibu, Timisoara, and Jerin. So these are the three cities reachable from Arad. So you have Shibu, Timisoara, and Jerin. So now you have to look for the distance of Shibu, then Timisoara, and Jerin. So now you have 253 for Shibu, and you have for Timisoara it is 329, and Jerin it is 374. So I told you it is a greedy best first search. So every time if you want to expand a node, you have to make sure that f of n is equivalent to the h of n, and that h of n is of what the lowest or the cheapest path you have to select. So now out of this, this Shibu is what the least distance. So 253. So now what I do, I will be expanding Shibu. So from Shibu, you have to look for the reachable. states. From Shibu, you can reach Pegasus and you can go to Erodia and Riminku and again back to Erer. So, which is not required, right? So, from Shibu, you could reach Fagaras, Oradhya, and Riminku, and now you have to look for the least one. And now the least one is what? The Fagaras. So, now the Fagaras will be expanded and in Fagaras you could reach, so you have to look the map. From Fagaras you could reach what? Bucharest, or you could take the another way like from Fagaras to Shibu, remove Pedesti and then you will reach what? Bucharest. So now from Fagaras you could reach Shibu again and from Fagaras you could reach what? The Bucharest, which is our destination. So likewise in greedy best search, so every time you have to make sure that equation, that is f of n, evaluation function f of n is equivalent to the heuristic function h of n. And you know the measuring the performance metrics, that is whether the problem could be solved completely and time and space complexity, and whether the solution what we obtain from this is optimal or not. So it is not a complete solution, because if suppose if the that is if the person stuck up within the loop and every time he or she can bounce back and forth between the cities, though it's like a loop, so you could not solve the problem. And again the time and complexity, since you are like it has to record all the notes in the memory, so obviously the space is what going to increase. But you could apply it, so based on the heuristic what you are applying, so you could reach the what that next node, that is love goal. And if you could not obtain an optimal, I mean complete solution, so optimal solution is not possible with greedy best first search. Thank you.